Today, our new topic, Redox reactions, chapter 8. It is the concepts of oxidation, reduction, all these are very familiar to you. I have studied it in lower classes. What is the classical concept of oxidation? The classical concept of oxidation is the addition of addition of oxygen to an element or to a compound. Addition of oxygen to an element or to a compound, that is oxidation. Or we can consider it as the removal of hydrogen from a substance. Removal of hydrogen from a substance. Example, oxygen is added to magnesium. Then it will be oxidized to magnesium oxide. 2 Mg plus O2 gives 2 MgO. Hydrogen is removed from H2S. So H2S is oxidized to sulfur. 2H2S plus O2 gives 2S plus 2H2O. It is oxidation. Addition of oxygen or removal of hydrogen. Or reduction. What is reduction? It is removal of oxygen from a compound or addition of hydrogen. Removal of oxygen from a compound or addition of hydrogen to a compound or to an element. Example, mercuric oxide, oxygen is removed. Then mercuric oxide is reduced to mercury. CH2 double bond CH2 ethene. To this compound, hydrogen is added. You will get ethane. Addition of hydrogen. It is reduction. Removal of oxygen is reduction. Addition of hydrogen is reduction. If you observe these reactions, you can see along with oxidation, there is reduction. H2S, you can see here, hydrogen is removed from sulfur, but at the same time, hydrogen is added to oxygen, H2O. Hydrogen is added to oxygen. So always an oxidation is followed by a reduction, or always a reduction followed by an oxidation. These two takes place simultaneously. So if we consider a reaction, if there is oxidation, there is reduction also. If there is reduction, there is oxidation also. So such reactions can be named as redox reactions. Now, redox reactions in terms of electron transfer. That is electronic concept of oxidation reduction. What is oxidation in electronic concept? Loss of electrons. That is oxidation. Half reaction that involve loss of electrons are called oxidation reaction. Similarly, the half reaction that involve gain of electrons are called reduction reaction. So oxidation, loss of electron or electrons by any species. Atoms, molecules, or ions. Reduction, gain of electron or electrons by any species. Atoms, molecules, or ions. Oxidizing agent or oxidant, that is the acceptor of electron. Oxidizing agent or oxidant, acceptor of electron. Reducing agent or reductant, donor of electrons. Reducing agent or reductant, that is donor of electrons. Here we can see Na combines with the Cl2 to form NaCl. Sodium is converted to Na plus by the removal of one electron. So two sodium atoms, a total of 2 electrons are removed and changed to 2Na plus. At the same time, chlorine accepts 1 electron and changes to Cl minus. So Cl2, 2 chlorine atoms are present. These 2 chlorine atoms can accept the electrons released by sodium to form 2Cl minus. So we can identify it as the oxidation half and it has the reduction half. So here, sodium is oxidized to Na plus, oxidation half, loss of electron. Oxygen is reduced to O2 negative, gain of electron, reduction. Here, 2Na is oxidized to Na plus, loss of electron, oxidation. Sulfur is reduced to S2 minus, gain of electron, reduction. Now, competitive electron transfer reactions. Especially it is observed in the case of metals based on their electropositivity. The metals which more electropositivity has the more tendency to give electrons. So if there are two metals which has more tendency to give electron, that will donate electron or that will be oxidized. That is competitive electron transfer reaction. It is explained with an example here. Copper sulfate solution is taken in this beaker, and to this beaker a zinc rod is inserted. Now observe what is happening. After some time the blue color that is decreased. Again after some time the color completely disappeared. Intensity of blue color first decreased and finally disappeared. So here actually what is happening, when zinc rod is dipped in copper sulfate solution, when you compare zinc and copper, zinc has more tendency to give electrons. So zinc will give electrons to this solution and will change it to Zn2 plus, and that released electrons will be accepted by copper. Cu2 plus combines with electrons to form copper, and that will be deposited here. You can see this brownish color that represents copper. And here the complete copper deposited as copper metal. That is the reason. And zinc is going into solution. So here competitive electron transfer, competition between zinc and copper. And zinc has more tendency to give electrons, or the power is more for zinc. So zinc is giving electrons. So zinc and copper. Here zinc rod is immersed, that means zinc plus Cu2 plus present in the solution. Zinc will give electrons, release 2 electrons and will change it to Zn2 plus, and that released electrons are accepted by Cu2 plus and will be reduced to copper. Similarly, when we compare copper and nickel, copper has more tendency to release electron and it will change it to Cu2 plus, and that released electrons will be accepted by Ni2 plus and that will be reduced to Ni. It has a lot of application. Galvanic cell, for making galvanic cell, these competitive electron transfer reactions are utilized. That we will study at the end of this chapter. So here you will get questions such as, is it possible to store copper sulfate solution in zinc vessel? Is it possible? No, it is not possible. Why? If you take copper sulfate in zinc vessel, the zinc will give electrons and it will enter into the solution and copper will be deposited. So we can expect damage to the vessel. So it is not possible to store copper sulfate in zinc vessel, but the opposite is possible. Storage of zinc sulfate in copper vessel is possible. Copper cannot displace zinc. Okay, our next topic is oxidation number. You are familiar with the oxidation number. What is oxidation number? It is the charge left on an atom when all other atoms of the molecule are removed as charged ions. For example, you consider H2O. H2O, 2 hydrogen atom and 1 oxygen atom are present. Suppose we removed the two hydrogen atoms are H plus ions. Then what is the charge remaining on oxygen? That will be 2 negative. So oxidation number of oxygen is 2 negative. Minus 2 is the oxidation number. So what is oxidation number? Oxidation number denotes the charge left on an atom when all other atoms of the molecule are removed as ions. Which is removed as ions. Complete transfer of electron is assumed. In this method, it is always assumed that there is a complete transfer of electron from a less electronegative atom to a more electronegative atom. Assign oxidation number is very important, and you have to practice it very well. Otherwise, you cannot balance redox reaction. So in order to assign oxidation number, we have to remember certain things or study certain things. The first one, oxidation number of an element is 0. Oxidation number of O2 is 0, 2 oxygen atoms. In O2, oxidation number is 0. Oxidation number of hydrogen in H2 is 0. So in elemental state, oxidation state is 0. And for ions composed of only one atom, Al3 plus, O2 negative, the oxidation number is equal to the charge on there. So Al3 plus, what is the oxidation number? 3 plus. The oxidation number of oxygen in most of the compound is -2. Most of the compound means there are exceptions. In almost all compound it is -2. There are exceptions. In peroxides it is -1, and in superoxides it is -1/2. Peroxide example H2O2, Na2O2, superoxide KO2, potassium superoxide. And fluorine is the most electronegative element. When oxygen combines with the fluorine, the oxidation state will be +2. That you can see in OF2, oxygen is in +2. In all other cases, oxygen in -2 oxidation state. The oxidation number of hydrogen is +1 except when it is bonded to metals. In metals, it is -1. So in NaH, hydrogen -1, but in CH4, hydrogen +1. HCl, hydrogen +1. In all its compounds, fluorine has an oxidation number of -1 because it is the most electronegative element. So in all compounds, fluorine has an oxidation number of -1. The algebraic sum of the oxidation number of all the atoms in a compound must be 0. If a molecule is separated into positive and negative ions, when you add the charges on the positive and negative ions, should get 0 because the molecule as a whole is neutral. But if it is a polyatomic ion, the algebraic sum of all the oxidation numbers of atoms of the ions must be equal to charge on the ion. For example, NH4 plus, what is the charge on the ion? +1. So the algebraic sum of oxidation numbers must be equal to 1. Nitrogen oxidation state is -3, hydrogen +1. So 3 minus -3, nitrogen -3, 4 hydrogen. 4 into +1. -3 plus 4 equal to +1. Now the oxidation state of alkali metals +1 and the oxidation state or number of alkaline earth metals +2. Remember these things now, we can find out the oxidation state of certain atoms in these molecules. First one, sulfur in H2S. Now to find out the oxidation state, what is the oxidation state of hydrogen? +1, because it is attached to a non-metal. How many hydrogen atoms? 2. So 2 into +1. Plus, we have to find out oxidation state of sulfur. So you write here X, and the algebraic sum is equal to 0. 2 plus X is equal to 0, or X is equal to -2. Carbon in CO2. Carbon give X. Oxygen -2. 2 into -2. Algebraic sum is equal to 0. So X minus 4 is equal to 0, or X is equal to 4. Now CH2Cl2, X, carbon X, hydrogen 1, 2 into 1, and chlorine -1, 2 into -1. And the algebraic sum is equal to 0, or X is equal to 0. Now energy for twice SO4. Here it is formed by 2 ions, energy for plus and SO4 2 negative. 2 ions, energy for plus and SO4 2 negative. Here nitrogen is present in this positive ion. So we can find out oxidation state of nitrogen from this ion. Nitrogen, you give it as X. Hydrogen +1, 4 into +1. And the algebraic sum is equal to 1. So X plus 4 into 1 is equal to 1, or X plus 4 is equal to 1. X is equal to 1 minus 4 equal to -3. Na3PO4, sodium +1, oxygen -2. So 3 into +1 plus X plus 4 into -2 equal to 0. Or 3 plus X minus 8 equal to 0. X minus 5 equal to 0, or X is equal to 5. Here are some homeworks for you. You have to find out the oxidation state of these compounds. So here, for example, NaH2PO4, sodium +1, hydrogen +1, oxygen -2. We have to find out oxidation state of phosphorus. Oxygen 4 into -2, -8, plus 2 into +1, 2, -8 plus 2, -6, plus sodium +1, -5, -6 plus 1, -5. So -5 is remaining. To neutralize that -5 charge, only phosphorus is present here. So what is the oxidation state of phosphorus? +5. Another question. Here you have to find out the oxidation half and reduction half. You have to assign oxidation number. Hydrogen, what is the oxidation number? +1. So what is the oxidation number of sulfur? -2. Chlorine element 0. +1, -2, 0. In HCl, hydrogen is again in +1. Chlorine in -1. Sulfur here 0. Elemental state 0. So sulfur in -2 oxidation state changes to sulfur in 0 oxidation state. -2 to 0. Increase in oxidation number. Or removal of electron, that is oxidation. So it is oxidation. Cl2, 0 is the oxidation state. And here in HCl, -1 is the oxidation. 0 to -1, gain of electron. So it is reduction. Similarly, you have to identify the oxidation half and reduction half in these two equations. Next question, justify that the reaction 2Cu2O plus U2S gives 6Cu plus SO2. How to prove that it is a redox reaction? Assign oxidation state to these compounds. Oxygen -2, 2 copper atoms, 2 copper atom has a charge of +2. So 1 plus 1. Here copper in +1 oxidation state and oxygen in -2 oxidation state. Here copper in +1 and sulfur in -2. Here copper in 0 oxidation state, +1, 2, 0. Copper is reduced. And sulfur -2 to +4. +4 is the oxidation state. So sulfur is oxidized. You have the proof. So you have to find out the oxidizing agent and the reducing agent. So here sulfur is undergoing oxidation. S2 minus oxidized to S +4. So it is the reducing agent. And Cu plus is reduced to Cu, and that is the oxidizing agent. Stock notation. What is stock notation? There is a method of writing molecular formula of metal compounds in which the oxidation state is given in bracket in Roman numerals. That method of representation is known as stock notation. For example, Au4Cl4 auric chloride, Ag2 1Cl2, Ag2 silver. This is the oxidation state of silver. Ag2Cl2, 2 is the oxidation state of silver here. Sen2Cl2, 2 is the oxidation state of tin here. Sen4Cl4, 4 is the oxidation state of tin here. L2O3, oxidation state of aluminum in this compound is 3, therefore it is given as L2,3O3. Representation of molecule in this way is known as stock notation. You are asked to write the stock notation of these molecules. It is solved in the textbook. You can see the answers here. First you try, then only have to check the answers, whether you can write it or not. I think it is enough for today. All of you study the oxidation number very well and to assign oxidation number. Okay.